Alright, so now that we know how to multiply fractions, we're ready to actually talk about what an equivalent fraction is and simplifying. So let's start off with equivalent fractions. When you look at these fractions, they all appear different because there's numbers involved are different. But the fraction, being a ratio, these numbers are working together where in fact all these fractions represent the same part of a whole. Because that essentially is what a fraction represents. It represents a part of a whole. So even though the denominator here is 4, the fact that we only have a 1 up here is equivalent to having an 8 in the denominator and a 2 up above, or a 12 in the denominator and a 3 up in the numerator, or a 16 in the denominator and a 4. These all represent the same part of the whole. What's different is the story behind them, or how the whole is broken up. So for example, if we start with 1/4, what we're talking about, I love pizza, so let's talk about one whole pizza. Alright, and what the 4 is telling us to do is how to break up that whole pizza. We're going to be breaking it up into 4 equal parts. And then the 1, that might be the one piece of pizza that I decide to chow down on and eat. So here's a picture of what one whole pizza would look like, right, if I ate 1/4 of it. So that little chunk right there represents 1/4 of the entire piece of pizza. Now of course if I come over here to the 2/8, let me try to draw about the same size of pizza. What's happening here is we're no longer breaking it up into fourths, but we're actually breaking it up into eighths. So again, same size pizza, same whole amount, but it's now broken up into eighths, and we're using 2 of them. So I'm going to shade in 1 and I'm going to shade in 2. And so notice that this 2/8, even though these slices of pizza are a little smaller, since I'm using 2 of them, 2/8 of a pizza is equivalent or the same part of a whole as 1/4, and so forth and so forth and so on. So on this one it's going to get harder to draw, but if I had one whole pizza, again this time the denominator is telling me to break it up. This is going to get pretty crazy. We're going to break this up into 12 pieces. Alright, so I think I'm going to do it this way. Notice that the slices of pizza get a lot smaller. So it's the same pizza, but we're going to be using 1, 2, and 3 of those. Alright, and I think I messed up, but I hope you guys get the idea. 1, 2, yeah, I think I've actually broke that up into 16ths. I drew a good picture of 16ths. I'm going to use that since I screwed that up. But there's basically a picture. We did 1, 2, 3, 4 of the 16 pieces. So again, this represents the same part of a whole as 2/8 and 1/4. If I was to draw a picture of 3/12 and do better, it'd be the same thing. There'd be 12 slices, and then we'd be using 3 of them, and we would represent the same thing. So again, equivalent fractions are essentially fractions that represent the same part of the whole, even though the story behind it, we're breaking things up into 16ths and using 4 of them. We're breaking a whole up into 12ths and using 3 of them. We're breaking things up into 8ths and only using 2 of them. We're breaking things up into quarters and using 1 of them. All those have the same picture behind them, so they represent the same part of a whole. And that's the whole idea behind an equivalent fraction. Alright? So now that we have an equivalent fraction, right, there's multiple ways to say the same thing basically. That is the challenge about fractions. All 4 of these, and there's even more. If we, 5/20 and 6/24, these are all ways to represent 1/4. So kind of does get a little confusing, but the whole basis is that these are all the same picture of 1/4. And so that basically leads us to simplifying a fraction. Basically, to simplify a fraction, we have to divide out all the common factors. Now remember, a factor is when we're breaking things up into a product. So we got to divide out all the common factors from the numerator and the denominator. We're essentially building an equivalent fraction. So let's take the 6/24 that I was talking about earlier, right? This breaks up, if we look at the common factors, 6 and 24 share a common factor of 6. So I can write the top as 6 times 1, and I can rewrite the bottom as 6 times 4. And what you'll probably see is we literally have 6 over 6, which is 1. And so this reduces or simplifies down to the fraction 1/4. That's kind of a way to prove that this fraction here and this fraction here represent the same part of a whole. That's what it means to simplify a fraction. We're dividing out, notice there's kind of a 1 there, right? 6 over 6 is 1. We're dividing out a common factor. And that's what it basically takes to reduce. Same thing, I think I had 3/12 earlier, right? Well, that's, 3 and 12 share a common factor of 3. So if I broke that up into products, 3 is 3 times 1, and 12 is 3 times 4. And then the 3's divide out, leaving us with an equivalent fraction of 1/4. So again, this fraction and this fraction and this fraction, they're basically all equivalent fractions because I reduced or I simplified these two down to that one right there. Sometimes there's a magic trick. I'm kind of literally showing you the factorization that I'm doing. But, if we had something like 5 over 20, the magic trick that probably confused you, but hopefully if you understand the dynamics behind it, I'm thinking that, the common factor between 5 and 20 is 5. So 5 goes into itself once, and it goes into 24 times, leaving us with 1/4. Of course, the work would actually look like this. 5 times 1 and 5 times 4. The 5's divide out, leaving us with 1/4. So if you need to see this breaking down, I would suggest you do it for a while. But if you're sufficient at looking at common factors in your multiplication tables, then maybe this little trick works out really nice. Just kind of continuing to work. Let's just say we had the fraction 10 over 12. Right? Looking at this, again, if you want a shortcut version, 10 and 12 share a common factor of 2. Right? And so, 2 goes into 10 5 times, and 2 goes into there 6 times, leaving us a simplified version of 5/6. Of course, the work would look like this. 10 over 12. Well, 10 is 5 times 2, and 12 is, 6 times 2. Getting ahead of myself there. The 2's divide out, leaving us with the 5/6. So again, to simplify a fraction, what we're doing is we are taking away, or excuse me, not taking away, we are dividing out common factors. And essentially what we're doing is we're building an equivalent fraction. So it's kind of another way to prove that two fractions are the same, is to make one into the other. And so, yeah, that's basically how we have that, to simplify fractions. And now when we put this all together, we can go back and look at a problem that we had earlier in the year where I asked, or excuse me, in these videos, where I was asking you to take 4/5 and divide that by 6 over 7. Of course, in an earlier video, we said, well, to divide, I multiply by a reciprocal, and then when I multiply top to top, and I multiply bottom to bottom. All right, and at this stage of the game, I told you I'm going to stop, but now that we know how to simplify, we can go forward. Again, magic trick, 28 and 30 share a 2 in common. If you don't see that, 28 is 2 times 14, and 30 is 2 times 15. So there's a common factor of 2, and that leaves us with 14 over 15. All right, so we finally completed that problem. We divided and we simplified at the same time. Of course, on this note, and here's where things get a little confusing, I would make sure you probably show that step to yourself. But another way to kind of do this, some students, and I'm one of, because I'm a little more proficient and my math, I'm comfortable with it, some students kind of can see the common factors right here. And so here's what the magic trick will look like, right? 4 and 6 share a common factor of 2. So 2 into 4 goes in twice, and 2 into 6 goes in 3 times. 2 times 7 is 14, and 5 times 3 is 15, giving us the same simplified version. So you can either do it the long way, if you would, to multiply and then see common factors and bring them out, or since we're multiplying, you can go ahead and divide out common factors, kind of I think the name people use this is cross-cancellation, but I don't like cross-cancellation at all because it thinks of zero and cross-multiply and all that. And all we're basically doing is finding the common factor between what's upstairs and what's downstairs, and we're dividing out that common factor. So that's how that works. Let me do one more example, and then we'll shut this down. But let's just say we had 3/7, and I was dividing this by, let's say, 9/10. All right. Again, the rule says to take the first fraction and multiply it by the reciprocal of the second. And of course, there's two schools of thought here, right? For some who are pretty proficient, like up here, I can see that the 3 and the 9 share a common factor. So let me rewrite it over here. So I would kind of do that magic trick and say 3 goes into itself once and goes into there 3 times, giving us 10/21. Of course, over here we can think of this as 30/63. All right, and then you can kind of see that 3 is common. The top is 3 times 10, and the bottom is 3 times 21. Divide out the 3's, and there's our answer of 10/21. So again, the key concept here is when you are simplifying a fraction, it's all about dividing out the common factors from the numerator and the common factors from the denominator and building equivalent fractions. All right, so that hopefully clears up some things about equivalent fractions and simplification, and because of that, we're now ready to add and subtract. So I'll see you in the next video.